Hello everybody, we are going to work through the rest of surface area and volume for pyramids. And so now we're looking at all types of pyramids, not just rectangular pyramids. So the number of bases that we have in a pyramid, a quick review, we only have one. That's what makes it a pyramid. We have one base. Today, we're going to look at pyramids with any shape. So any polygon shaped base. So that could be a triangle. It could be a quadrilateral. It could be a nonagon with 9 sides. So we're going to look at pyramids with any shape base. The number of lateral faces is going to be dependent on the base. So it's the number of sides on the base. So yesterday we were talking about rectangular pyramids, which had, just 4 sides on the base. So it had 4 lateral faces. But today we are going to have any number. And then the shape of the lateral face, it's still going to be a triangle. That's what makes it. So that's part of the definition of a pyramid. All right, so a quick review for the formulas. It says write the formula for a lateral area, surface area, and volume of a rectangular prism. So the lateral area, remember, is 1/2 times the perimeter of the base times the slant height. That's down the side of the pyramid. The surface area is the area of the base plus the lateral area. And the volume is, it's pointy, so we divide by 3, so 1/3 of the area of the base times the height. So a couple things to remember. These can only be used when the base is regular. Okay, otherwise you use the net. So you actually unfold it and find the area of each region, okay? One other thing to remember, that the height is perpendicular to the base. And the slant height, it's called slant height because it's slanted, is on a lateral face. So it's the height of a lateral face. Okay, so you already have those in your notes from yesterday. All right, let's jump in with some examples here. So what I don't like about this example is that it does not indicate that this is regular. So, oh yes it does, I'm sorry. I was missing this 2 yards here, I was not seeing that. So we've got a triangular base on this pyramid with 2 yards, 2 yards, and 2 yards. So it is indeed regular. I still think it's a really good idea to just be in the habit of drawing your base off to the side. Right, so this is an equilateral triangle where each side is 2 yards. And then it gives us right here, the altitude of the base is 1.7. So that we can find the area of the base relatively easily. And then it gives us the slant height. So let's go ahead and start with the lateral area. So the lateral area is 1/2 of the perimeter times the slant height. And the perimeter of our base, right? So we've got 2, 2, 2. So our perimeter is equal to 6. And our slant height is that side that goes down if you were sliding down the side of the pyramid. And so our slant height is 1.2. So our total lateral area here is 1/2 of the perimeter, which is 6 times 1.2. Okay, so half of 6 times 1.2 is a total lateral area of 3.6 square yards. And there's our total lateral area. Now, for our surface area, we just need to do the area of the base plus our lateral area. Our lateral area was 3.6. And to find the area of the base, our base is a triangle. So we're going to do the area of a triangle, which is 1/2 base times height. And remember, we're talking about the base and the altitude of that triangle. So our triangle has a side length of 2, and its altitude is 1.7. That was given. And the area of our base is just 1.7. Half of 2 is 1. 1 times 1.7 is 1.7. So we're going to find our surface area to be 1.7 plus 3.6. And let's see here. I don't know why I'm using a calculator, but the total surface area is 5.3 square yards. Okay, so that's lateral area and surface area. Those aren't too bad. The one that is going to take some work is the volume. So I'm going to erase my lateral area and surface area. Cooper wants to say hi.
Hi.
And then he's going to go back to eating his goldfish and watching Frozen, but he really wants to make you a video of his own, so I think we'll do that a little bit later. Okay, so volume. So I am going to erase everything and so that we can focus on the volume, because the tricky part about the volume is that we need the height of the pyramid, and the height of the pyramid, it's not there. We don't have it, so we have to figure it out. All right, so clear my ink, and we're going to start with volume. So volume is equal to 1/3 of the area of the base times the height of the pyramid. So we just had that area of the base. I erased it, but you know. So that was 1/2 times, let's see here, I'll just do it over here. 1/2 times the base of the triangle times the height of the triangle, which was 1.7. Okay, so the base is 1.7, and remember that's square yards because that's representing the area of the base. Now the height. So the height of this pyramid goes from the vertex of the pyramid and is perpendicular to the base. Now you have to think about what's happening here. Your base is an equilateral triangle, okay? And the pyramid's like apex point, the vertex, it's smack dab in the center. So that height hits that circle in the center. And then we need to be able to find it. So if we're going to call this H, okay, we need to be able to connect it into a right triangle with something else to be able to find it. So then you think about, well, it intersects the slant height, and the slant height is right there. It's 1.2 yards. And then if we connect at the base, the slant height and the height, we get this segment right here. So let's think about where the slant height hits the triangle. It hits it right here. Okay? And so if we're connecting that, and that's that green segment, so this is the base, like if we were looking down on this, that is the apothem, right? That is the apothem of our triangle from our regular triangle unit. So our right triangle, to be able to find the height, is going to require that we have, oh, I didn't want to do that. Is going to require that we have this right triangle where we have the height of the actual pyramid, and that connects to the apothem of the base, or the apothem, and those two both are connected by the slant height of a lateral face. Okay, so can you see how this triangle relates to this cross section of the pyramid? It's like half of a cross section. Well, it's not even half, but it relates here, okay? And then, so in order to do this, so we know that our slant height is 1.2. we know that that's it. That's all we know. So then we have to find the apothem from our base. So we go back to our base. Our base is here. And each side of our base, I'm going to use this red triangle, is 2, 2, and 2. So remember the apothem divides it in half. So this is 1 and 1. And then we need to actually find the apothem here. So we're going to use the radius. Okay, so if we go back to the regular polygon unit, right, or those lessons from the area unit, we remember that we had to find that angle theta. So we did, to find that, 360 divided by 1, 2, 3 angles. So theta is equal to 120, but then remember the apothem divides it in half to a 60-degree angle. Okay, so now we're trying to find this apothem right here so that we can use it also here to be able to find the height of the pyramid. Okay, so we're going to find, let's see here. We know this is a 30, 60, 90 triangle, and we've got the long leg, and we need to go back to the short leg. So the apothem is equal to 1 divided by root 3. And when you rationalize that, you get root 3 over 3. And so the apothem is equal to that, root 3 over 3. Now, our slant height is in a decimal form, so we can go ahead and change our apothem to a decimal as well. And that is 0.58. So this is about 0.58. Okay, so now we find our height using the Pythagorean theorem. So we've got two sides of this right triangle, and now we're going to find our height using the Pythagorean theorem. So 0.58 squared plus 1.2 squared is equal to, that is not what I am doing. Woo, that was a hypotenuse, sorry. Okay, 0.58 squared plus h squared is equal to 1.2 squared. And let's see here. We're going to take the square root. We get h squared is equal to 1.1036. We're going to take the square root of that. And that's 1.05. Okay, so for our actual volume, we can do it now. Our height is 1.05. Our volume is equal to 1/3 of the area of the base times 1.05. And our total volume is about 0.6 cubic yards. 0.6 cubic yards. So it was 0.0595. Okay. So, you know, sometimes you have to like really work for parts to be able to solve for them. There's not a lot of this that you're going to see, but there are a few. And so it's connecting the dots between what we've done with regular polygons and then applying them in solids. So, okay, so we've got 2 more examples. If you feel like you've got it and you want to give the homework a go ahead. Otherwise, you can stay tuned. All right, so let's look at example number 4. So we are going to find, this is a regular pentagon for our base. So this is a pentagonal pyramid. 1, 2, 1, 2, 3, 4, 5 sides, so a pentagonal pyramid. So our base is a pentagon. Ooh, that looks bad. It's regular. You can see all the angles are congruent, all the sides are congruent. Each side length has a side of 8. What's really nice here is that we have been given the apothem. So we have it right there. It is 5.5. So to find our, let's go ahead and start with our lateral area. So our lateral area is half of the perimeter times the slant height. the perimeter is 8 times 5, because we've got 5 sides, so it's 40 yards. And our slant height has been given right here as 8.9. So slant, slide down the side of the pyramid. So that's 8.9. Okay, so total lateral area, half of the perimeter times the slant height is half of 40 is 20 times 8.9 is 178 square yards. Now, for the total surface area, we need to take the area of the base, there's only one, plus that lateral area, so that's 178. And for the area of the base, remember this is a regular polygon, so that formula was 1/2 times the apothem times the perimeter. The apothem is given as 5.5. Yay, this time that we have it. And the perimeter is 40. We already figured that out. So let's see. The area of our base is 110 square yards. And we need, for total surface area, to add our base to our lateral area. So we get 288 square yards for our total surface area. Okay, the good news on the volume, it's going to be much more straightforward because we've been given the apothem. So that's going to make that much easier. So I'm going to erase the lateral area work. And our volume formula is 1/3 times the area of the base times the height of the pyramid. So the base we already figured out was 110. The height, we have to figure that out. So remember, height goes from the vertex, I think the apex is another way of saying that, and it's perpendicular. So here's our height. Remember, it connects with the apothem, and those both are connected with the slant height. So you get this right triangle. And in this particular right triangle, we have everything that we need to just use the Pythagorean theorem. So we're looking for the height. That's our unknown. This is the apothem. It's 5.5, and the slant height here is 8.9. So yippee, this time we just get to solve for the height, we just get to use Pythagorean theorem. So h squared plus 5.5 squared equals 8.9 squared. And let's see here. It is 6.997, so we're going to round that to 7. And our volume is going to be 1/3 of 110 times 7. And that is about 256.7. And we are in cubic yards. All right, so that one wasn't so bad because the apothem was given to us. So, okay. One more, the last one, number 5, is a regular hexagon. And again, we're given the apothem and the slant height, so and the side length, so this shouldn't be too bad. But let's take a look at, we have 2 more. What am I saying? All right, let's take a look at number 5. Actually, oh yeah. We'll just do it. Okay, so again, here we go. Lateral area, we are doing 1/2 times the perimeter times the slant height. This base is a regular hexagon. Ooh, my iPad drawing skills are a little rough. All right, and let's see here. We have a base of 8. We have an apothem of 6.9. And so that makes our perimeter 8 times 6, which is 48. And our slant height was given, and it is right here, 13 yards. Okay, so total lateral area, half of the perimeter, which is 48, times that slant height is 13. So 24 times 13 is 312 square yards. And then for our total surface area, we need the area of the base plus that lateral area, which is 312. Our base is a regular polygon, so we need to find 1/2 of the apothem times the perimeter. The apothem is given as 6.9, and the perimeter is 48. Cooper is back. All right, so we've got the area of the base is 165.6 square yards. So our total surface area, okay, so our total surface area, 165.6 plus 312 is 477.6, and we are in still square yards. Okay. All right, volume. So volume is, I wanted to switch colors. Volume is 1/3 of the area of the base, which was 165.6, times the height of the pyramid. Now here we go again. The height goes from the vertex and is perpendicular and intersects with the apothem and the slant height. I think I just swapped my colors, but that's okay. And it makes a right triangle. So we're looking for the height. So for our height, I'm going to draw that right triangle. We have our height, our apothem, and the slant height. And so we're going to do the Pythagorean theorem. And we've got, let's see here. H squared was equal to 121.39, so H is about 11.02. Okay, so our volume is equal to 1/3 of 165.6 times our height, which is 11.02. And we get, let's see here, 608.3. And that's cubic yards. So there we have our volume. All right, number 6. I'm going to set it up, and then I'll go ahead and work through it. But if you feel like you understand it, it has a triangular base, so you might want to work through it with me. All right, sorry, I got interrupted by a 4-year-old again. So I was saying I'm going to set this up. It has a triangular base, so you might want to stick around, but it's up to you on how you think things are going. All right, number 6. And of course it doesn't give me, oh wait. Oh, it does give me some space. All right, a pyramid with a slant height of, I don't really care yet, whose triangular base, that's what I want to work on. So I want to draw this first. So if it has a triangular base, I'm going to give myself a triangle. And then a pyramid just needs a point above it, and then you just connect each vertex. So there's my pyramid with my triangular base, and it doesn't say it's equilateral. It really should say it's equilateral. but because we have no other information, we're going to assume it's equilateral. Ooh, I hate that. You know how I feel about that. All right, so now I'm going to label the dimensions. It has a slant height of 11.4. So a slant height of 11.4. kilometers. This is a ginormous pyramid. I don't know what world we're in where we have pyramids that big, but and then a triangular base measures 10 kilometers on each side. Oh, I guess that does indicate that it would be regular because it's 10 kilometers on each side. Okay. Each altitude of the base measures 8.7. So the altitude of the base would be the height of the base. So that might be like here, not the greatest picture, but that is 8.7. Okay, so lateral area first. Lateral area is half of, it's still regular. Remember that you can use the formulas when the bases are regular. In today's lesson, the bases have all been regular. All right, so lateral area is 1/2 times the perimeter times the slant height, the one that slides down the side. So our perimeter is 10 times 3. Our slant height is 11.4. Our total lateral area is half of 30 times 11.4. And that is 171 square kilometers. Our total surface area is the area of the base plus our lateral area. And our base is a triangle, right? We've got an equilateral triangle where each side is 10. And then it told us the altitude of our base, that was this blue line, was 8.7. So we know that the area of our triangle is half of the base 10 times the height or the altitude of the base, which is 8.7. So the area of our base is 43.5. So surface area is 43.5 plus 171. And we get 214.5 square kilometers. Okay, so once we have sorted all of that out and got our picture drawn, that wasn't so bad. And now we get to do the fun part, which is the volume. So remember that volume is, I like that purple. I need to add that into my, let's see here. Now I'm getting distracted. Ooh, okay. Volume is 1/3 of the area of the base times the height. We have our base. We figured that out with surface area was 43.5. Here's that hard part, the part that we don't, it's just so much fun, is finding the height. So the height of the pyramid has to connect with the apothem and the slant height. So we need to erase, first of all, because we need to get a clear picture of what's happening here. Oh my gosh, I only have 1 more minute left. So, okay, I'm gonna pause and I'm just gonna write. Okay, so what you can see here is I drew the right triangle where our apothem connects to our height, connects to our slant height from here. And I drew the base because we need to find the apothem. So now I'm going to pause the video again and then all my work will show up for the apothem. Okay, so now you can see that my work for the apothem it's down here. Okay, so remember this was a 30, 60, 90 triangle, so I just divided by √3. I got about 2.9, and now I'm going to use the Pythagorean theorem and solve for h. Yay! Okay, so I used the Pythagorean theorem, and I solved for H. H was about 11.0. I plugged that into the volume formula and got my answer. Sorry about that. Bye!